Here we are in EP Biology. This is a discussion of Chapter 34. In this video, we'll be focusing on the actual examples of the different biomes that are in the Earth's biosphere. So this is part 2 of this video. What we have here is we're going to start with what are the aquatic biomes. So ocean is what, or salty water is what occupies most of Earth's surface. When we look at the patchiness of Earth, we're going to see that most of it is that water. It turns out, though, that ocean is not just ocean. There are characteristics that determine what is going on in the ocean. So the first thing is how much light is something getting in the ocean, because that determines what kind of organisms can live and thrive there. And then we need to talk about how far away from the shoreline, or how far away or how deep is the bottom of the ocean, because that'll make a difference of what kind of organisms are present. And then lastly, we'll be talking about what kind of nutrients are available in the area. And this could be, is photosynthesis able to happen? Are heterotrophs or autotrophs present? Are we near a deep sea ocean vent where there is a lot of sulfur and not a lot of carbon? So that's all can be a factor in what kind of animals or organisms are present in an aquatic biome. One of the most famous ones, that are the ones that we're most easily able to see, is the intertidal zone. So if we look at the intertidal zone, what we're going to find is that when we look at the intertidal zone, what we're going to be finding is we're looking right here where the water meets the shore. So this is our intertidal zone. And there is where you find tide pools. So things like starfish and sea anemones. If you're lucky, you might find an octopus that's been trapped in the area. But these are animals that live in partly submerged in water, partly exposed onto land, and they are oftentimes sedentary or attached to rocks. Now, as we move through this, when we talk about some of the ocean zones, oftentimes I think we'll think of the theme song, or that something that's present from Finding Nemo.
Oh, let's name the zones, the zones, the zones. Let's name the zones of the open sea.
Hang on, Nemo.
You better stay with me. Ecologic, methodologic, ecologic, all the rest are too deep for you and me to see. I wonder where my class has gone.
So as we can see, even Finding Nemo decides to discuss the different areas of the zone. When we talk about the intertidal zone, that's your tide pools. Then we'll talk about our continental shelf, which is usually the area that you can walk on, or you can see with your own naked eye. The photic zone is exactly what it sounds like. It's the area that's exposed to the sun. And then we have the benthic zone, which is the sea floor. So depending on how deep the sea floor is, that's where you'll find your benthic zone. This is also where you find those deep sea floor volcanoes. The aphotic zone means without light. And so we'll find out what kind of organisms can survive with no light. And then, of course, there's the pelagic zone. Now, when we talk about all the different ocean zones, I think the one that we're most familiar with, or the one we're most comfortable with, besides tide pools, is the coral reefs. And because the coral reefs are so beautiful, they're often found in the warm waters that are above the continental shelf. Now, what happens with this idea, if you look here, here's your continental shelf. We're looking at something that we can quickly and easily see. This is the area of the ocean that was mainly focused on, again, in Nemo, where all of our kind of coral reef animals live. It's often highly dependent upon the amount of sunlight that it can get, or the large amount of sunlight that it gets. When we go away from ocean environments, we're going to talk about estuaries. What an estuary is where fresh water, so this is fresh water, where fresh water actually flows into the ocean. An ocean is salt water. So this is where fresh water and salt water meet. This is where a river turns into an ocean. We have estuaries all around us. Now, the thing about the plants and stuff that live in an estuary, which is this area right here, they have to be able to survive not only fresh water, but salt water as well. Freshwater, or strictly freshwater biomes, are things like lakes, like Lake Tahoe, ponds, rivers, streams, and then the wetlands. Now, ponds and streams and lakes and stuff are affected by the amount of light they get, what temperature they are, and then the availability of nutrients and dissolved oxygen. And so it's much similar to, or it's very similar to the ocean environment. However, we're looking at a fixed body of water, except the rivers and streams. But a lake is a fixed body of water that's surrounded on all sides by land, and so that can play a huge factor into what is the environment of the water itself. So it turns out that abiotic factors can change from the source of the river to the mouth of the river, and the mouth is where it feeds into the ocean. So it turns out if you were to look at a river, you might think of something like this, where it's flowing water bubbling over rocks, and it has ginormous shaded trees. It's very beautiful. However, by the time the same river flows and it reaches where it kind of meets the ocean, then you're looking at more of a marshland, more of those flat grasses, maybe some birds. We're also looking at a connection or where freshwater animals can meet saltwater animals. So this is often where something like a salmon is going to run into a sea lion, where we don't have sea lions necessarily in a fresh river, but we do find them in the ocean, and they know where those sources are, and they'll look for them. And this is where we can also have the connection where in those shallow waters, we'll start to see different kind of life or animal forms around. Wetlands are the swamps and marshes. This is an example of what one looks like. And when we go a little bit bigger and we start talking about, okay, well, if that's what the oceans or the water, bodies of water look like, let's talk about the terrestrial biomes. So the biomes that we can find in the different regions. And they are a reflection of their location on the biosphere and how much sunlight they get. And so what we're going to do now is we're going to kind of look at all of the different terrestrial biomes. So here it is. This is the equator. So we'll be talking about our equator right here. This is where the most sun is. This is very, very warm and sunny area, and that's where we find those tropical rainforests. Hot temperatures, lots of rainfall. When we look at the areas that have very little water or very little rainfall, we're looking at the deserts. So here's that desert that we were previously talking about right here on the easterly side of the Sierra Nevadas, because all the rain has already been dumped out. It's very dry air that comes down, and that's where we find our desert. And then if you notice at the tops of the poles, so down at the North Pole and at South Pole, what we find is we get our tundras, and the tundra is where you get all of your snow. So let's look at some of the specific types of biomes. So we'll start with our tropical rainforest. The tropical rainforest is found near the equator, and it's very diverse, very popular, very powerful. Oh, shoot, this is paused. Oh, no, I'm good. And it has a lot of rain. It also is where you have the most diversity of species. The next one that we're looking at are savannas. This is where, like, the African savanna. These are very dry, very warm. There's very, very few trees that are around, if you can see these. Mostly we're looking at grasses, and that's how the name comes from. When we talk about deserts, we're talking about a lack of water. And if you look at where the deserts are, they're often slightly above or below the equator, but not at a pole. So here we have this blown up version you can see on the map. The orange areas indicate all of the deserts. You can see that they, again, are not at the equator and not at the poles, but somewhere in between. This is the one that is most popular, the one we should recognize the most. This is Cloverdale. And Cloverdale has rainy winters, which we're currently experiencing. We have cool, dry, and hot summers. And we have shrublands. And shrublands are kind of these little dense, scrubby things that deer hide in. And this is what we have. So this is our chaparral. It is what is our current or local biome. Some of the other examples is the broadleaf trees that are famous in the eastern coast. Oh, this doesn't go in front. I apologize. And they're often found at mid-latitude. So you can see this. Here's mid-latitude. What that means is it's somewhere in between the poles and the equator, just like the deserts. However, there is enough moisture there to allow ginormous trees that are deciduous to exist. Whereas that's different than the coniferous forest that we often have. This is Lake Tahoe. In Northern California, we also can call it a taiga. And that's where there's short summers, but there's long, snowy winters. So anywhere that you can have snow, you can have a coniferous forest as long as there's enough water to allow the trees to grow. If you have a lot of snow and it's just bitterly long cold, then what you have is your Arctic tundra. Your Arctic tundra is treeless, and that's because there's only snow, not water from rain, which means we can't grow big trees. So everything that happens is these tiny little grasses that can grow within the permafrost, and permafrost just means the ground is permanently frozen. One of the things that happens is a specific type is the alpine tundra, and basically what happens is you'll look up at a mountain, there'll be growing trees, and all of a sudden there's no more trees, and it's just this teeny tiny little grasses that we see here. And that's when you're above the tree line, and there's literally not enough water from that snow to allow big trees to grow, and so we're stuck with kind of this area. There's also not enough soil that's not permanently frozen for the roots to grow in. Now, one of the ideas about understanding the different types of environments is we can understand the interaction with them. And as I started the first video with, is that humans have a huge impact on the environment. And there is an ecologist, his name is Ariel Lugo. He does seminars all over the world, and he's basically studying tropical forests in Puerto Rico, specifically so that we can say, what happens when we tear down a forest to put in farmland or to harvest crops? What happens when we get rid of all of the diversity that is present in a rainforest? Does that impact the kind of the larger biosphere, or is it just the impact just remain in that one local biome area? And so we're starting to look at that and understand that we do play a critical role in the overall health of the entire planet.